Hello, hello. Hello everyone. Good evening to all of you. So today we are going to have a session on operating system subject with respect to ISRO examination. So we all know that recently ISRO have given notification for recruitment of for the recruitment of scientist posts. So as part of that, we are going to see operating system subjects related questions which are part of our previous year papers. Okay, so we all know that ACE Engineering Academy is providing you a series of lectures for the benefit of the students with respect to this ISRO examination. So first of all, we are going to see what is the syllabus of operating system, and then we can see the previous year questions of this ISRO examination. Right. So you can see that the syllabus of operating system, it is very similar to GATE examination itself. Okay, so previously also I told when we have conducted a session on computer network subject, by the time I've clearly mentioned that one preparation is enough to crack both GATE examination and ISRO examination. So by keeping that in mind, let's see the weightage of this operating system with respect to this ISRO examination. So this is the table which can indicate you the weightage of operating system or along with all other subjects. But if you verify the weightage of this operating system, it is in top position. You can see that it is in top position. Look at this particular one. Operating system, from operating system, see these are all number of questions. If you consider in 2007 we are having 14 questions. If you consider 2008 we are having 18 questions. And if we consider 2009 we are having 12 questions. Like this, if you verify the total number of questions from all the previous year papers, around 10 papers if we consider, from all these 10 papers or else 11 papers of history, if you verify, from all the subjects of computer science, from operating system you have more weightage. 128 number of questions are there. There is no other subject apart from this subject which is having that much weightage. And of course you are having computer networks also. This is what the next highest subject, which is already dealt in our previous session. But in this session we are going to see this operating system and look at the importance of this operating system. 128 number of questions we are having from past 10 years if we verify. So it means that around 12 to 13 questions we can expect. This is what the summary we can give based on this table. Okay, right. So let's start the questions, and if you are a part of my live session, please try to give whenever I display the question statement to you, so that you please respond to me that we can have an interactive session here. Right. So look at this question. This is the question which we have in 2007 from this operating system subject. So what is the answer for this question? Please verify. So it is related to aging concept. The term aging refers to option A, booting up the priority of the process in multi-level queue without feedback. Option B, gradually increasing the priority of the jobs that wait in the system for a long time to remedy infinite blocking. Option C, keeping track of the following page has been in memory for the purpose of LRU. And option C, letting the job reside in memory for a certain amount of time so that the number of pages required can be estimated accurately. So what is the answer for this question, guys? Please check this question and let me know what is the answer. So it is related to aging concept. So we have covered this aging concept in our regular classes. If you have attended those sessions, you can easily answer this question. So what is that aging concept? So aging refers to you are increasing the priority of the process in proportional to the waiting time of the process. If the waiting time of the process is been increasing, then obviously the priority of that process also gets increased. This is what the concept of aging. So corresponding to that, if you verify, option B is the answer for this question. So basically this aging is the solution for, it is the solution for what, tell me? It is the technique or else it is the solution for which one? Starvation. So to avoid starvation, we can use this aging concept, right? So if you consider SJF algorithm, shortest job first algorithm, in shortest job first algorithm, starvation is possible to the lower job, starvation is possible to the higher jobs if there is a continuous flow of lower jobs into the ready queue, right? So then, if what is the meaning of lower what is the meaning of lower job and what is the meaning of higher job in the sense? Higher job in the sense which is having higher burst time, lower job in the sense which is having lower burst time. As it is shorter job first, it prefers only lower jobs, means whichever process is having less burst time, that process can be preferred. So those process gets executed first than the process which are having higher burst time. So which means that if there is a continuous flow of shorter jobs into the ready queue, then obviously the longer jobs can experience starvation. So to avoid such starvation situations, we can use this aging concept. So aging means what we are saying, that increasing the priority of the process in proportional to the waiting time of that respective process. So option B is the answer for this question, right? Let's move to next question. So look at this question, which you can easily answer to this. So consider a set of n tasks with known run times R1, R2, R3 and so on Rn to be run on a uniprocessor mission. Which of the following processor scheduling algorithm will result in the maximum throughput? We need to think of this maximum throughput. So which of the algorithm can give maximum throughput if you verify? So what is the answer for this question, guys? So you can slightly answer to this question as SJF concept, SJF scheduling algorithm. So how you can say SJF? Because if you have executed longer jobs first prior to the, if you are executing longer jobs first prior to the shorter jobs, obviously the waiting time, the average waiting time of the system is going to be very high. But if you execute the shorter jobs first than the longer jobs, then obviously the average waiting time of the process can be low. So if average waiting time of the process is low, obviously the throughput of the particular system can be maximum. So by having this explanation, we can say option B is the answer for this question, because in SJF, the scheduler is executing, or as the CPU is executing shorter jobs first. So since shorter jobs are being executing first than longer job, obviously the average waiting time of the system, average waiting time of all the process in the system is going to be minimum. If it is minimum, throughput can be high. So by keeping this discussion in mind, we can say option B is the answer for this question. So this kind of theory points we have covered in our regular classes. If you refer the lecture notes, you can easily answer them. And I told you, I told you already in our classes, like or else we used to tell in our classes, if operating system should be like, you have to prepare both numerical as well as theoretical. Operating system is how much theory we are having, that much amount of numerical we are having. But if you look into the CN, more numeric and less theory. But here operating system is having both topics, like theory topics and numerical topics are having equal weightage. And if you verify all these questions, mostly these are all the theory points, and these points are presented in our regular classroom lecture notes, right? So option B is the answer for this question. Next, let's move to next question. Yes, look at this question. The principle of the locality of reference justifies the use of dash. Option A, virtual memory. Option B, interrupts. Option C, main memory. And option D, cache memory. So what is the answer for this question, guys? Please look into this question, everybody. So principle of locality, that's what it is. We have to see that locality of reference principle, locality of reference principle. So what is the meaning of locality of reference principle? The meaning of locality of reference principle is, it is a program segment where more number of references are available. This is what the meaning of locality of reference principle. So among the given options, in which one we are using, or else which program, or else which option is executing on this locality of reference principle, if you can verify, you can easily say that option D is working on this locality of reference principle. You know what is the concept of the cache memory? Cache memory, generally it stores the most frequently used data as well as instructions as part of cache memory, right? So we used to store most referred data as well as instructions we used to store in the cache memory rather than in main memory. So the main importance of the cache memory is we want to reduce the effective access time of memory. So for that purpose, what we are doing, the most referenced data as well as instructions we are storing into cache memory. This is called, you can say, locality of reference concept. So this is also we have covered in our classes, right? So option D is the answer for this question, right? So let's move to next question. So look at this question, everybody. Round robin schedule is essentially the preemptive version of what? Option A, FIFO, option B, SJF, option C, shortest remaining time first, and option D, longest remaining time first. So please respond to this question. What is the answer for this question, guys? I am giving you 10 seconds of time because it is theory questions, right? Simple questions. So what is the answer for this question? Round robin scheduling algorithm is essentially the preemptive version of dash. So if you verify round robin scheduling algorithm, you check with the criteria. So what is the criteria that we are using to select one process from ready queue onto the CPU if we are using round robin scheduling algorithm? What is the criteria? On which criteria this round robin scheduling algorithm is working? Please verify. It is working on arrival time plus time quant. Arrival time and time quanta is the criteria here, right? So what is the other scheduling algorithm? Among the options, if you verify, what is the other scheduling algorithm that is working on this arrival time? That is FCFS, or else you can say FIFO. So round robin is a preemptive version of FIFO, or else a preemptive version of FCFS. So hence, by keeping this description in mind, we can say option A is the answer for this question. Okay? So let's move to next question. So coming to this question, what is the statement of this question? Please verify. What is the name of the technique in which the operating system of a computer executes several programs concurrently by switching back and forth between them? Option A, partitioning. Option B, multitasking. Option C, windowing, and option D, paging. So what is the concept? What is the technique that we are using here? Please verify. What is the name of the technique in which operating system of a computer executes several programs concurrently by switching back and forth? So tell me what is the answer for this question, guys. So you can say, what is the answer? Option B is the answer for this question, multitasking. You know that multitasking means what? Multitasking means what? What is the main goal of this multitasking? What is the main goal of this multitasking operating system? Please verify. So the main goal of this multitasking operating system is the CPU should keep on switch from one process to another process. The CPU should keep on switch from one process to another process. So the CPU is not allowed to sit with only one process for long amount of time. It should keep on switch from one process to another process so that response time of the system can be good here. So by keeping this goal statement in mind, we can say answer for this question is multitasking, right? So this is what the explanation for this question. Right. So let's move to next question based on this operating system as part of ISRO PYQs. Right. So look at this question, everybody. What is the answer for this question? What is the answer for this question? If you can verify, virtual memory, option A, part of main memory only used for swapping. Option B, a technique to allow a program of size more than the size of the main memory to run. Option C, part of secondary storage used in program execution. And option D, none of this. So what is the answer for this question, guys? So virtual memory, basically this virtual memory, what is the definition of virtual memory? If you recall that, you can easily answer this question. So what is the virtual memory concept? It gives an illusion to the end user. So what is the definition of virtual memory? Look at it. It gives an illusion It gives an illusion to the end programmer. It gives an illusion to the end programmer. It gives an illusion to the end programmer that even though the program size is, even though the process size, the size of the process, even though the size of the process, even though the size of the process is higher than, even though the size of the process is higher than the main memory size, the main memory size, the main memory size, the main memory size, still we can execute. Still we can execute. We can execute, or else the programmer can execute. This is what the definition that we can give for the virtual memory. So by keeping this definition in mind, by keeping the definition of this virtual memory in mind, what can be the answer for this question? You can say option B is the answer here. So basically this virtual memory is the combination of both main memory as well as secondary memory. It is not exclusively main memory, it is not exclusively secondary memory. So whatever the thing that we are having, part of secondary storage used in, see basically there is one more concept called swap space. What is that one more concept? Swap space. So swap space is actually part of this virtual memory concept and it is part of the secondary memory. But virtual memory is the combination of both main memory and secondary memory. This swap space is exclusively secondary memory. Okay? So hence we can say option B is the answer for this question. If you know the definition of virtual memory, you can directly opt option B is the answer without any waiting, right? So this is what the answer for this question, option B is the answer, right? So we have given all these definitions, theory points in our lecture notes itself. You can verify that, right? Then coming to next one. So look at this question. Disk requests are received by disk drive for a cylinder 5, 25, 18, 3, 39, 8 and 35 in that order. A seek takes 5 milliseconds per cylinder moved. How much seek time is needed to serve these requests for SSTF algorithm? SSTF. What is the meaning of SSTF? SSTF stands for shortest seek time first, right? Shortest seek time first. Shortest seek time first. SSTF stands for shortest seek time first. So what are the disk requests we are having? 5, 25, 18, 3, 39, 8 and 35. And currently assume that the arm is at cylinder 20. So currently we are having cylinder 20. Okay. So just assumption we are having 100 number of cylinders. Let's say if you consider, see that is ranging from let's say 0 to 99. Just assumption it is. Okay. So now what is the first one we are having here? Let's say 3 we are having first. Then we are having 5 we can write, and then we are having 8 we can write. So 3 is over, 5 is over, then 8 is over. After that we are having 18. After that we are having 20. After that we are having 25. And after that we are having 35. And then 39. So all we have considered, right? All disk requests we have considered. Fine. So initially the read-write head is at 20. Let's say here we are having disk read-write head is at 20. So from 20, as it is shortest seek time first, whichever is nearer to this current head position or else current position of the read-write head, from that what is the nearest one if you verify among the disk requests? Which one is the nearest one? 18. So from 20, the disk request, the disk read-write head moves to 18. So what is the travel distance here? 2. Then from 18, is it goes to 25 or else is it goes to 8? So the distance from 18 among the remaining unserviced disk requests, which one is shorter in distance? If you verify, from 18, 8 is in 10 distance. From 18, 25 is in 7 distance. So that this is in shorter distance. From 18, the disk read-write head moves to 25. So what is the travel distance? 7. So from 25, is 35 is in shorter distance or else 8 in shorter distance among the unserviced disk requests if you verify. From 8, 17 is, but 25 to 35 is 10. So means this is in shorter distance. So 10. Then from 35 among the unserviced disk requests, which is in shorter distance, if you can verify, you can find 39 is in shorter distance. So that's why disk reader head can move to the 39 from 35. The travel distance is 4. Then among the unserviced disk requests like 3, 5, 8, which one is in shorter distance? From 39, if you can verify, 8 is the in shorter distance. So that's why from 39, the disk reader head moves to 8. So what is the travel distance here? 39 minus 8, which is 31. So from 31, it goes to 5. From 8, it goes to 5. What is the travel distance here? 3. So from 5, it goes to 3. This is the last unserviced disk request, and what is the travel distance? 2. So therefore, it is asking you about how much seek time is needed to serve these requests, means we have to service all these disk requests, means it is asking us to calculate total head movements or else total seek time. So total seek time we have to calculate here. So we have to calculate total seek time here. So coming to the seek time, it is clearly mentioned that the seek time, a seek takes 5 milliseconds. Seek time in the sense what? From the current head position to the desired track, how much time it takes the disk reader head to move, that is called seek time. So that is given 5 milliseconds, right? So now what is the total head movements if you can verify? 7 plus 2, 9, 9 plus 10, 19, 19 plus 4, 23, 23 plus 31, 23 plus 31, 23 plus 31 if you can verify, 54, 54 plus 3, 57, 57 plus 2, 59. So the total head movements, therefore, total head movements we are having here, total head movements is equals to 59. But what is the travel distance it is given? What is the seek time it is given? 5. So which means that the total seek time is equals to total head movements into seek time. So 59 into 5. So what is the 59 into 5 if you can verify? 59 into 5 if you can verify. 5 9s are 45. 5 5s are 25 plus 4, 29. So 295 milliseconds is the answer for this question. So hence option B is the answer for this question, right? So this is a way how we can handle these questions, right? So this is part of our file system subject, file systems chapter we have covered in our regular classes, okay, right? So let's move to next question. Yeah, so this is the question we have from deadlocks concept, please verify. Consider a system having m resources of the same type. The resources are shared by 3 processes A, B, C, which have peak time demand of 3, 4, 6 respectively. The minimum value of m that ensures the deadlock will never occur is option A 11, option B 12, option C 13, and option D 14. So what is the answer for this question if you can verify? So look at, we are having how many number of processes here? So number of processes is equals to 3. Next, how many number of resources we are having? Number of resources is equals to m. So if you can check our discussion in our regular classes, if you can verify, number of process we have considered as n, right? And number of resources we have considered as m. So then, in order to deadlock never arise, what is the condition that we are having? Demand of all processes, which is demand I is less than m plus n. This is the condition that we are having in order to say that deadlock will never arise in the system. So what is the demand of all processes if we verify? All these 3 processes are having this much demand. What is the demand? 3, 4, 6. So 6 plus 4, 10, 10 plus 3, 13. So demand is 13 here. Total demand is 13. 13 is less than m we need to find out plus what is the n value? 3. So then this is going to be 10 is less than m. So as the question is asking about minimum number of m, so 10 is less than m, the same I can write m is greater than 10. So what is the values that we are having more than 10? 11, 12, 13, 14. For all these values, deadlock will not occur, but it is asking you minimum. So minimum value of m should be, this is the minimum value. So for minimum value of 11, deadlock will not occur. For the maximum value of 10, deadlock will arise. This is the maximum value of m for which the deadlock can be possible, but the minimum value of 11 of m, deadlock will never arise. So 11 is the answer for this question. For all these values, we won't face deadlock, but as the question is clearly mentioned that minimum, 11 is the answer for this. So option A is the answer for this question. So how this formula is being, we are getting that formula derivation also we have clearly given in our regular classes. Yes or no? Right. So now coming to next question. Right. So look at this question, everybody. Simple question. A task in a blocked state. A task in a blocked state. A task in a blocked state. Option A is executable. Option B is running. Option C must still be placed in the run queues. And option D is waiting time for some temporarily unavailable resources. Is waiting for some temporarily unavailable resources. What is the answer for this question? If you can verify, blocked state, no, it is saying that blocked. Blocked in the sense, you know that this is also called as waiting state. Waiting state. So if any process wants to perform some IO operation, that process is moving from running state to waiting state. So in the waiting state, it is entering into device queue and it is waiting for a free IO device to perform some IO operations, right? So which means that a process is waiting for an IO device in order to perform IO operations. So where it is waiting? In the device queue. So that is what is the corresponding explanation for this question? I mean, what is the corresponding explanation, whatever we have given, what is the corresponding key here? If we verify, option D is the answer for this question. So it is waiting, a task in blocked state is waiting for some temporarily unavailable resource. It is unavailable resource. IO device is busy, but a process is waiting in the device queue in order to perform some IO operations. So that option D is the answer for this question. Okay, right. So let's move to next question. So check this question. Semaphores. Option A, synchronize critical resources to prevent the deadlock. Synchronize critical resources to prevent contention. Option C, are used to do input or output, are used for memory management. So what is the answer for this question? Semaphores. Actually, what is the definition of semaphore? Semaphore, it is a inter-process synchronization tool. It is a inter-process synchronization tool. It is a inter-process synchronization tool. It is an inter-process synchronization tool. Right? Semaphores is an inter-process synchronization tool. So it is used to synchronize the critical resources to prevent the deadlock is the answer for this question, because you know that if generally in order to access the critical resources, there is a possibility that deadlock can be happened. That is what one problem, you can say, one risk condition you can say, if we don't have synchronization among the cooperative process when they are trying to execute the shared resources. So by that moment, there is a possibility for occurrence of loss of data. There is a possibility for occurrence of inconsistent results. There is a possibility for occurrence of deadlocks. So in order to synchronize those cooperative process to avoid all these situations, we are using one of the solution called, one of the solution to the critical section problem is OS based solution, that is called your semaphore. So semaphore is an inter-process synchronization tool. What does it mean? It is used to avoid various inter-process synchronization problems. One of the problem is deadlock. So this is what the answer for this question. Okay, right. So let's move to next question. So what is the answer for this question? Option A. Check this question. 4 jobs to be executed on a single process system arrive at time 0 in that order A, B, C, D. Their burst CPU time requirements are 4181 time units respectively. The completion time of A under round robin scheduling algorithm with the time slice of 1 time unit. So, what is the scheduling algorithm that we are using here? Round robin scheduling algorithm with time quanta of 1 unit. So, we have to find out completion time of A. So, start working on this. What is the answer for this question, guys? Please respond to me. So, here first we are building the Gantt chart, first we are building the ready queue, after that we can build Gantt chart. So, first we are moving to ready queue. So, it is clearly mentioned that at time t0 the processes are 4 jobs are arrived in this order A, B, C, D. In that order they have arrived. So, A is arrived, B is arrived, C is arrived and D is arrived. So, among the multiple processes in the ready queue, what is the process that is in first position? A. So, that is why the Gantt chart will start from A. So, Gantt chart will start from A. So, at 0 A can start its execution. So, how long this A can be executed? Only 1 unit. And what is execution time of A if you verify? 4. So, with this execution is the A is finished? No, which means that again we should add this A, we should remove this A from the front end of the ready queue and we should add it back to the ready queue. So, means A is again getting added at the back of ready queue. Then what is the first process we are having in the ready queue? B. It is going to be executed till 1 unit, means from 1 to 2. So, with this execution B is finished or not? Yes, because its execution time is just 1. So, since it is finished, no need of adding this B back to ready queue because its execution is over. Then what is the first process we are having in the ready queue? C. And with this execution, is the C is finished, verify, C's burst time is 8 units. So, with this execution C is not finished. So, that again the C can be added back to ready queue. Then the first process we are having in the ready queue is D. So, it is going to be executed till 4. And with this execution D is over? Yes, because its execution time is only 1 unit. So, that D is need not to be added back to ready queue. So, now the first process we are having in the ready queue is A. So, A can start its execution till 5 it gets executed. With this execution is the A finished in the sense no. So, that again this A can be added back to ready queue. Then what is the first process we are having in the ready queue? C. This can be executed till 6 and with this execution is the C finished in the sense? No, again this C can be added back to ready queue. Then what is the first process in the ready queue? We are having A and this A is going to be executed till 7 and with this execution is the A finished? No, means again this A can be added back to ready queue. Then what is the first process we are having in the ready queue? C. C can start its execution till 1 unit. Every time 1 unit only because it is time quanta is given. The process's execution is depending on the time quanta. So, this is time shared system, right? So, now with this execution C is finished and then again C can be added back to ready queue because its execution is not yet finished with this execution. Then what is the first process we are having? A. So, it is going to execute till 9. So, with this execution is the A finished, have a look. So, total execution time of A is 4 out of which 1, 2, 3, 4, 4 is over. So, 4 total execution time of A is over. So, then what is the completion time of A if you verify? 9. At 9 A is getting finished. So, now need not to add this A back to the ready queue, only C can start its execution like this. Continuously only C can start its execution. This is the way how we build the ready queue and Gantt chart for this given system. So, then what is the answer for this question if we verify? The completion time of A is at 9. So, option D is the answer for this question. So, I hope you are clear with this question and its corresponding explanation. We have done so many questions on round robin in our classes, okay, right. So, now we are moving to next question, right. So, look at this. This is even slight previous year gate question also, but slight modification. What is the question statement? Which of the following need not necessarily be saved? Need not necessarily be saved on a context switch between the process. So first of all, what is the meaning of context switch? What is the meaning of context? You have to verify. What is the meaning of context? Context means attribute of a processes. Attributes of the processes. Attributes of a process is called as context. So what are the attributes we are having for a process? The attributes are like process ID, process state, process priority, process program counter, then general purpose registers, GPR, then list of open files, list of open devices. Like this, there are so much of information. So much of information needs to be saved with respect to one process, and with respect to another process we must load. That is what the meaning of context switch. What is the definition of context switch? Process of saving the context of one process, saving the context of one process, and loading the context of another process, and loading the context of other process. This is called context switching. So what is the meaning of context in the sense? Attributes, collection of attributes, right? So this is all you can say context switch. So which of the following is need not to be necessarily be saved during the context switch? This is what you have to verify. So if you can verify, general purpose registers is a attribute. So compulsory it has to be saved. It has to be saved. Program counter is, if you can verify, it is also compulsory, needs to be saved. But translation look aside buffer, it is need not be saved. Need not be saved. Reason, actually the intention of the translation look aside buffer is reducing the access time, reducing the memory access time. To reduce the effective memory access time, or else to increase the system performance, we are using this translation look aside buffer, so that translation look aside buffer is need not necessarily be saved during the context switch between the two processes. Hence option B is the answer for this question, because this is being used for improving the performance. It is used for improving the system performance. It improves system performance. Okay, right. So now we are moving to next question. So coming to the next question, I hope you are clear with this question. Option B is the answer. Let's move to next question. Yeah, so look at this question, feedback queues. Feedback queues, it is asking about the feedback queues. Option A are very simple to implement. Option B, dispatch task according to the execution characteristics. Option C are used to favor real-time tasks. Option D require manual interventions to implement this properly. So what is the answer for this question, guys? Please respond to me if you are online. So what is the answer for this? It is speaking about feedback queue, means you can see multi-level feedback queue. Multi-level feedback queue. Algorithm, you have seen process scheduling algorithm. So what is that multi-level feedback queue scheduling algorithm? If you can consider, this is one level of ready queue, this is another level of ready queue, this is another level of ready queue, and this is another level of ready queue. Let's say 4 level of ready queue we are considering. The multi-level feedback queue scheduling algorithm is flexible. Actually, this is flexible. How you can say this algorithm is flexible? Because it is allowing the process to move from one level of ready queue to the another level of ready queue. It means that a process can move from bottom level ready queue to the top level ready queue, as well as a process can move from top level ready queue to the bottom level ready queue also. So the meaning of feedback queue is, you can say that, let's say if you consider this direction, bottom to up, a process which is waiting here for long amount of time can increase its priority using the aging concept, and it can move to next level of ready queue. Again, it can wait some amount of time. Again, it increases its priority because its waiting time is getting again here increasing. Then this process can move to next level of ready queue like this. Then again, in this ready queue also the process can wait, and then while waiting is been increasing, obviously the priority of this process also gets increased. At some point of time, the process can move to top level ready queue, and it can be handed over to CPU. So this is what the feedback description. So a process can move in both directions. It can move from here to here, means from top level ready queue to the from bottom level ready queue to the top level ready queue, as well as from top level ready queue to the bottom level ready queue also a process can move. So that is why we are saying that it is flexible process scheduling algorithm. But on the other hand, you are having multi-level queue scheduling algorithm, but this is multi-level feedback queue. There is one more scheduling algorithm which is multi-level queue scheduling algorithm. It is not flexible because it is not allowing the process to move from one level of ready queue to another level of ready queue. So by having this entire description, what is the answer for this question? If you can verify, option B is the answer. Feedback queues dispatch the tasks according to executing characteristics, right? So this is the way. It means that, let's say if you consider at this level of ready queue, every process should spend only 2 units of time. After that, it has to move to the next level of ready queue. Here might be, it needs to be executed for 4 units of time, according to the characteristic of the, that's what, execution characteristic. A process is moving from one level of ready queue to the another level of ready queue. This is happening in multi-level feedback queue scheduling algorithm. Hence, you can say option B is the answer for this question. Okay. So I hope you are clear with explanation of this question, and we have discussed in our classes about this multi-level queue scheduling algorithm, multi-level feedback queue scheduling algorithm. Around 11 process scheduling algorithms we have covered. Please verify them. Okay. Right. So let's move to next question. Yeah. So look at this question. With round robin CPU scheduling in a time shared system, option A, using very large time slice degrades into FCFS algorithm. Using extremely small time slices improves performance. Using very small time slices degenerates into LIFO algorithm. Option D, using medium sized time slices leads to SRTF algorithm. So please verify what is the answer for this question, guys. This is also we clearly given, we have given in our regular classes. If you can verify the lecture notes, you can easily answer this question. What is the answer for this question? With round robin scheduling algorithm, if time slice is less, please verify. If we are choosing the less time quanta, or else the time quanta is too small, then the number of context switches can be more. If the number of context switches are more, obviously the system performance can be low. But here option B, it is mentioned that using extremely small time slices improves system performance, which is obviously wrong. It degrades the system performance because more number of context switches is the result if we are having very low time quanta. But when we consider very large time quanta, then you can say the performance of round robin degrades to FCFS scheduling algorithm. Hence, option A is the answer for this question. We have given the proof also in our classes and your lecture notes. If you can verify, we have given the proof for that. How if the time quanta is large, the performance of round robin can be equals to FCFS, and how the time quanta is very small, then number of context switches can be very more. That is also we have clearly given in our classroom notes. You can verify that. So option A is the answer for this question. Then look at this question. Thrashing, just if you recall the thrashing definition, you can easily answer it. Thrashing, option A, always occurs on large computers. Option B is a natural consequence of virtual memory system. Option C can always be avoided by swapping. And option D can be caused by poor paging algorithms. So it is asking about reasons of the thrashing. Please recall reasons for thrashing. What is the meaning of thrashing basically? Thrashing means you can say it is a high paging activity. It is a high paging activity, or else you can also call it is excessive paging IO. Excessive paging IO. Excessive paging IO. So this is what one definition for thrashing, this is what another definition for thrashing. Then what are the reasons for thrashing, if you can verify? Reasons. So we are having two types of reasons. Primary reasons are there. and secondary reasons are also there. So what are the primary reasons we are having? The primary reasons are like high degree of multiprogramming and lack of sufficient number of memory frames. Lack of sufficient number of memory frames. These are the primary reasons for occurrence of thrashing. Then what about the secondary reasons? If you can verify, secondary reasons, selection of page replacement algorithm. Selection of page replacement algorithm is one secondary reason, and the page size is also one reason. So by keeping this point, reasons for thrashing, if you consider this, by keeping this point in mind, among the options if you verify, thrashing can be caused by poor page replacement algorithm. Option D is the answer. You can verify this. The reasons if you can verify, secondary reasons, selection of page replacement algorithm is one secondary reason for occurrence of thrashing in the system. So option D is the answer for this question. Okay. So let's move to next question. So check this question. What is the name of the operating system that reads and reacts in terms of OS? Reads and reacts. Reacting means responding. So what is that system that is? Batch system, quick response time, real-time systems and time-shared systems. Which one is the correct answer if you can verify? Real-time systems. So real-time systems are reading your input and then reacts. Let's say if you consider your washing machine, the washing machine, you are giving some input to that like read operation. I mean, you can give a drain operation and wash operation, right? So if you give drain operation, then what will happen? The water can drain, or else if you give the spin operation, the washing machine can start spinning the cloths. Am I correct or not? So according to your input, it reads that and it reacts to that. So that is why we are saying that real-time system is the answer for this question, right? So let's move to next question. So this is one previous year GET question straight away. You can verify which of the following is an example of spooled device. So what is the meaning of spooling? So spool stands for simultaneous peripheral. Spool stands for simultaneous peripheral operations online. Simultaneous peripheral operations online. This is what spool stands for, correct? So what is the meaning of spooling? Process of placing the data for another program to execute. So look at what is the definition of spooling. Process of placing the data in a temporary buffer for another program to execute. This is what the definition of spooling. So the process of placing the data in a temporary buffer for another program to execute. So hence you can verify. The best example for this spooled device, you can say printer. Printer is a spooled device, and the spooling concept that we have used in batch operating system. So it means that after finishing of one job, after complete execution of one job, what is the meaning of complete execution? Both CPU and IO, both are completed. Then only the next process is scheduled for execution. So while one process is performing its IO operation, even though the CPU is idle, the other process is not allowed to select on the CPU. That is what the meaning of spooling concept, right? So hence you can say option A is the answer. A line printer, directly you can say it is used to print the output of the number of jobs is the answer for this question, option A, right? So let's move to next question. So dirty bit for a page in the page table. So this is one bookkeeping information. You know, a page table is having an entry which is frame number and bookkeeping information. This dirty bit is also called as modified bit, right? So what is the answer for this question if you can verify? It helps avoiding unnecessary writes on paging device. It helps maintaining LRU operation. It allows only read operation, read on page, or option D, none of these. What is the answer for this question? If you can verify, dirty page, dirty bit, I am telling you that dirty bit in the sense it is also called as modified bit. So modification in the sense you are doing some write operation here. You are not doing some read operation. You are doing some write operation. So corresponding to that term, what is the option you can verify? It helps avoiding unnecessary writes on paging device, which is option A is the answer for this question. Okay, right. So now we are moving to next question. Yeah. So this is another question we have. Overlaying, option A, requires use of loader. Option B, allows larger programmer but requires more effort. Option C, is most used on large computers. And option D, is transparent to the user. What is the answer for this question? Overlay concept. So this overlay concept we have used, prior to virtual memory concept. What is the virtual memory concept? Even though the program size is more than the main memory size, still we can able to execute. The same concept is overlays also. But only thing is, what is the main concept of overlays? If you can verify, whatever the portion that you want to execute, required portion, you first load it, execute it. After execution of that, again unload it. Then the next part of the process you can load into the main memory and execute that, again it can unload it. So like this, whatever the part of the process for execution it is required, only that process you just load it, execute it, unroll it. So this is the way how you are able to execute a program even though its size is more than the memory size, right? So this is what the concept of overlays. But the only headache with the overlays is implementation is a bit difficult. The programmer needs to give the overlay structure, which is not much easy. So that's why, so by keeping this entire description in mind, now you can check what is the answer for this question. Option B, you can say it allows larger programs. It allows larger programs to execute with the smaller memory, but more effort is required in order to build that overlay tree. Okay, so that's why option B is the answer for this question. Right. So let's move to next question. This is also a direct previous year gate question. A critical section is a program segment. Critical section. So the critical section contains what? Shared data, whereas non-critical section, which is your reminder section, contains shared data. So critical section contains shared data, whereas the reminder section contains non-shared data. So if you can verify critical section where the shared resources are accessed, you know that with respect to concurrency, the cooperative process structure is being defined like this. What is the structure of the cooperative process? Please verify. Structure of a process. Structure of a process, if you can verify, do, which is having entry section and then critical section, then exit section, and then we are having reminder section. So while of 1. This is what the structure of a cooperative process. So here we can have entry section into critical section. Here we have exit section from critical section. So overall, the critical section is restricted area. Both entry section and exit section is restricted, and this critical section contains shared resources or else shared data. Whereas the reminder section is not restricted, it is non-restricted, or else it is freely allowable, and it contains non-shared data. So by keeping this discussion in mind, you can say option C is the answer for this question. Okay, right. So let's move to next question. Look at this question. In which of the following 4 necessary conditions of deadlock, processes claim exclusive control of the resource they require? Exclusive control means only, the meaning of exclusive control is only one will have the control on the resource. Only one process can have the control on the resource. Then what is the corresponding definition if you can verify? Option B is the answer. Mutual exclusive. What does it mean? Only one process is allowed to use the resource at a time. That is what the mutual exclusion definition. So what is the definition of mutual exclusion? It defines that only one process is allowed. Only one process is allowed. Only one process is allowed to use the resource at a time. To use the resource at only one process is allowed to use the resource at a time. This is what the definition of mutual exclusion. So by keeping this in mind, option B is the answer, as it is clearly mentioned that claim exclusive control of the resources. Exclusive control means only that particular process can use, remaining processes are not used, not allowed to use. Getting me? So this is what you can say, option B is the answer for this question. Right. Then coming to this question, fork. It is a system call, you know. What is that fork statement here? What is that definition of fork? Please verify. What is the definition of fork? So generally this is a system call which is used for creation of a process. It is used for creation of a process. So directly you can say option D is the answer for this question. Okay, the creation of new process. Okay, so creation of new job, creation of new process, both are almost same. Okay, both options are almost same. Creation of a new job, creation of a new process, both are same. But this is not going to be correct answer for this fork. Okay, right. So option A and D can be the answer here. No confusion in this, right? So coming to next question. So both can be the answers here. Because you know that job is the term that we are using with respect to batch system, process is the term that we are using with respect to multi-programmed system. So both are same. So job, process, program, these are all interchangeable terms. Task, these are all interchangeable tasks, okay? Interchangeable words, right? So let's move to next question. Yeah, this is already we have solved. Which of the following need not to be necessarily be saved on the context of this is already we have solved, which is you can say translation look aside buffer, right? So let's move to next question. Yeah, so look at this question. Consider a logical address space of 8 pages of 1024 watts mapped onto a memory of 32 frames. How many bits are there in the logical address space? How many bits are there in the logical address? So logical address space contains 8 pages, 8 pages. So number of pages in LAS, number of pages in LAS is equals to LAS by PS. Number of pages is equals to, number of pages in LAS is equals to LAS by PS. How many pages we are having? 8 pages is equals to LAS by page size. What is the page size? It is given each page size is 1024 watts, which you can write as 2 power 10. So then that implies LAS is equals to 8 into 2 power 10, which you can write as 2 power 3 into 2 power 10, that is 2 power 13. So if LAS is 2 power 13, if LAS is 2 power 13, then what about LA? 13 bits. Yes or no? 13 bits. So since the question is asking about number of bits in the logical address space, you can say 13 bits is the answer for this question. But if the question is speaking about physical address, if the question is asking about the physical address, as it is saying that 32 frames, so PAS is equals to number of frames are 32, which you can write as 2 power 5 into each frame size is 2 power 10, which is going to be 2 power 15. Then your physical address space is 2 power 15. Your physical address space is 2 power 15, it means
Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determine for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determine for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you're all going to make ACE online platform as a part of your success story. ACE Online. Learn anywhere, anytime.
Hello, 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 hello. వస్తున్నది ఇలా అయితే ఈ right. So now we are going to see this what are the various courses that ACE Engineering Academy is offering for the benefit of the students. If we can verify, these are the various courses. As part of that, first I can say ACE online self-paced program, which is allowing you to attend or else allowing you to access the online live classes by the expert faculties, so that you can access those live classes, and you can also opt this course in subscription basis, like you can have 1 month subscription, 3 month subscription, 6 month subscription. So this is what one course that we are offering from ACE Engineering Academy. And then after this, we are having some other important course which you can consider in the last minute preparation, like quick revision course. This is very, very helpful to all of the GATE aspirants during the last month preparation, right? So this is what another course which we are offering from ACE Engineering Academy for the benefit of students. And this is what another helpful resource to the students, like in one module we have done almost all the previous year GATE questions as well as all ISRO questions in one module we have done, and you can see that a very huge amount of number of questions, 2000 plus questions is not a small effort. That is, we have taken around 200 hours of plus time duration in order to record 2000 plus questions, that is with respect to both GATE and ISRO, which is very, very helpful module or else course from ACE Engineering Academy to the benefit of students. Then after this, we are having another course, that is GATE Hindi courses. You can say that ACE is offering you the courses not only in the English version but also in terms of Hindi version. You can also access our recorded courses. We have done in both Hindi as well as English. So you can opt this course also, whoever is been comfortable in Hindi, right? So this is what another course we have. Then there is one more module or else one more course that is offering. I mean, this is what another helpful resource to the students who are been preparing for ISRO examination. We have prepared a book called, a hard copy in which you are having all previous year ISRO questions solutions with a in a neat manner we have given. So this is also a very helpful resource for the students who are interested to appear for ISRO examination. So I hope this session is helpful to all of you. Thank you. Have a great day. Good night.